Okay guys, so I'm gonna complete the part 2 for finding the maximum temperature for the previous example question. We can actually read the question. An air enters an engine working on the Otto cycle at 1 bar 303K and is compressed isentropically to 17 bar. Compressed isentropically to 70 bar, meaning PV diagram, PV, compressed 1 to 2. This is what we mean compressed isentropically, right? So when they say compressed isentropically, 17 bars, 1 to 2, and that's 2 to 3, that's isochoric, which the W will equal, there's no work done. There's V2 equals to V3, right? So 2 to 3 and 3 to 4, as we said in the previous example, W is 0. V1 equals to V4, V1 equals to V4, right? V2 equals to V3, isochoric expansion, isochoric compression, right? So we can go and complete to find the maximum temperature. And what do we mean by maximum temperature? This is the maximum temperature actually, max temperature. Okay, so we can go on and find the maximum temperature, which is T3, right? So we do know that P2 divided by T2 equals to P3 divided by T3. So we do have T2 and we do have P2, right? So we can work things out. And we do have P3. So heat addition raises the engine pressure to 30 bar. So 30 bar is actually P3. Heat addition raises the engine pressure to 30 bar. Engine pressure. So expansion. The more it expands, the higher the temperature. You know when you hear the sound of the vehicles of psss, that's expansion, right? So that's higher pressure. Heat addition, when you increase the heat, when you increase the temperature, we actually have more pressure. So P2 divided by T2, P3 divided by T3, we can work things out like T3. So T3 equals to T2 multiplied by P3 divided by P2. We can work things out like that, right? Constant volume process, which is V2 equals to V3. Okay, so T2 is actually 680, so 680.76 multiplied by 30 divided by 17, which finally equals 1201.35 Kelvin. Do the math, please. So it does make sense now that it's the maximum temperature, because you can look at the number, right? Now, the more we move downwards from like 3 to 4, 4 to 1, so we are expanding, right? There's isochoric expansion, and there's like 3 to 4, there's isentropic expansion. Okay, so it does make sense that this is the maximum temperature first, and it does make sense that if you want to find T4 will be lower than the maximum temperature, right? It does make sense because it's going downwards. If you can solve the PV diagram, guys, it's going to be a lot easier for you guys. So just let it make sense for you. Understand the philosophy behind it. Okay, so we do find that 1201 Kelvin for the maximum temperature of the cycle. How about the amount? The amount of heat supplied. Which is Qn equals to mCv T3 minus T2. So for the mass, for m equals to 1, you can actually work it out without like putting the mass, but okay, you can do that too. I'm gonna show you in the next video. So it's gonna be 1 multiplied by 0.719 multiplied by 1201 minus T2 680.76. Right? So when we do the math, we're gonna get 374.30 kilojoules of air, right? So does make sense, and I'm going to explain this point for the MCV, like how can we find it, because it's related to the ideal gas stuff, you know. But maybe in the next video, okay?